Hello students, and welcome to section 3-4, arithmetic sequences. To start this discussion for today, I do encourage that you take a look at the Explore and Reason, reading through the patterned fabric and depiction in an XY table kind of structure, as you can see, with the row number of patterned squares in the row, and total number of patterned squares. Take a look at that, and that'll be something that we could discuss during an office hours time, but also as it nicely segues into our lesson for today. Example, connect sequences and functions. So is the ordered list 26, 39, 52, 65, 78 an arithmetic sequence? We need to start off our discussion with really what a sequence is. More specifically, an arithmetic sequence, right? A sequence is an ordered list of numbers that often forms a pattern. Each number is a term of the sequence. In an arithmetic sequence, the difference between any two consecutive terms is a constant called the common difference. So if we take a look, the sequence of terms here that you see, are we increasing? It looks like we are, but also are we increasing by a specific number being added? Well, let's take a look. The common difference will play into this, hopefully, in a moment. Find the differences between pairs of consecutive terms. So we'll take all the terms kind of laid out as such and literally find the difference, particularly if you took 39 minus 26, 52 minus 39, 65 minus 52, 78 minus 65. It in fact ends up to where you do subtract to get 13 for every single difference. This is called the common difference. If the number is the same, the difference is the same, particularly we know it's common. There is a common difference of 13, so we argue that this is an arithmetic sequence. It's an arithmetic sequence because you add 13 to each respective term to get the next term in the sequence. Moving on. How are sequences related to functions? We know a lot about functions already. We talked quite a bit about linear functions, correct? Y equals mx plus b being the slope-intercept form of a linear function. Well, let's take a look. You can think of a sequence as a function where the domain is restricted to the natural numbers and the range is the term or terms of the sequence. Okay, so we've already talked about domain, we've already talked about range. Let's continue this idea. For the sequence that we just discussed, 26, 39, 52, 65, 78, let n equal the number or term number in the sequence. From there, let a of n, kind of like when we worked with the function notation f of x, let a of n, or y you could argue, equal the value of the nth term of the sequence. So this is like saying x equals the term number. This is like saying y equals the actual value. Let's continue from here. So a of 1 would be 26. The first term, as you see, is 26. While a of 2, the second term, is 39. So in a sense, you can kind of consider this like an ordered pair, wherein you're considering how, when we discussed ordered pairs in this particular notation, 1, 26, 2, 39. Okay? So let's continue. How do you represent sequences using subscript notation? Well, subscript notation is commonly used to describe sequences. So a sub 2 is equal to 39. The second term again is 39. You could also say a of 2 is equal to 39, but this is more typical when we denote what a sequence term happens to be. A sub 2, the second term, is 39. You can either use function or subscript notation to represent sequences. Let's discuss the next section where you're seeing here the definition. I'm just going to read through. It says recursive in mathematics means to repeat a process over and over again, using the output of each step as the next input. A recursive formula relates each term of a sequence to the previous term. It is composed of an initial value and a rule for generating the sequence. So the recursive formula for an arithmetic sequence is the following. So the first term of the sequence, again, we just discussed, would be something like this, a sub 1, or you could write it as a of 1. Okay, and then the nth term of the sequence, as we see here just below, a sub n, and that's equal to the previous term of the sequence, a sub n minus 1, and then lastly plus d, again the common difference, which we've also discussed. Let's talk a little bit about a sub n and a sub n minus 1. Let's, for the sake of argument, let's say that I wanted a sub 5. If I wanted the fifth term in the sequence, okay, a sub 5 would be, again, what I'm finding, but here, what is a sub n minus 1? Well, if 5 is n, then 5 minus 1, this would be 5, like I said, but this would be 4. So you could actually find the fifth term, a sub 5, if you know the fourth term, a sub 5 minus 1, or a sub 4. And that would be as easy as taking the fourth term and adding the common difference. So in the last problem, I didn't, didn't have, well, 1, 2, 3, 4, 5. We did have 5 terms. But let's say you knew the fourth term and you knew the common difference. You can find the fifth term, a sub 5. So a sub 5 would be equal to a sub 4, which is 65, plus 13. And again, that's 78. Recursive formulas or rules. This is a formula they were describing. I'll also call it a rule sometimes, but recursive formulas are great because you can find the next term if you know the previous term. If you have a sub 4, you can find a sub 5. Again, a recursive formula describes the pattern of a sequence and can be used to find the next term. Okay. Moving on. Example 2. Apply the recursive formula or rule. What is a recursive formula for the height above the ground of the nth step of the pyramid shown? Each step is 26 centimeters tall. It does say be careful not to assume that the first term and the common difference are the same. That is a very important thing to denote. Let's take a look. So we're going to use the recursive formula wherein a sub 1, the very first term in the sequence, is 26. Since each step is the same height, d, we're going to go ahead and denote this as follows. A sub n is equal to a sub n minus 1 plus 26. So not only is the first term 26, each term thereafter is adding 26 to the prior term. Okay, so that there, hopefully you can see that that speaks to then generally speaking, and I'll move this down and over, how you can devise really the next term in sequence. So a sub n equals a sub n minus 1 plus 26. It gives the height above the ground of the nth step, with the first term again being 26. Okay, so we're going to continue to add 26. So if we start with 26, we add 26, we add 26, we add 26, and so on and so forth. It says use the recursive formula to find the height above ground of the third step. So find the height above the ground of the second step. You can't find the third term until you know the second term. And you can't find the second term until you know the first term. So a sub 1 we already said is 26. And we also, of course, have the d value or common difference of the same value. That's not always going to happen, by the way. Okay, as this error suggests. Be very careful. The fact that these two numbers are 26, okay, is not something that you'll regularly see. It just so happens to be the case here. Because we have the first term as 26, and because we know every term after is just 26 added to the prior term, we're going to take 26, which is a sub 1, plug it into the following. So a sub 2 is equal to a sub 1 plus 26. So use that knowledge And of course, you've got the second step to be 52. And so on and so forth. Now it says find the height above the ground of the third step. So a sub 3, first denote a sub 2 again is 52, but a sub 3 should be equal to a sub 2 plus 26. And again, because we already have 52 as a sub 2, we're going to use it, adding 52 plus 26, and in fact you get your third term to be 78. So the third step is 78 centimeters above the ground. You can continue this pattern by simply adding 26, add 26, add 26. A calculator can give you this particular sequence if in fact you just typed in 26 and hit enter, and just plus 26 and hit enter, 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 and so on and so forth. So your calculator is able to give you, based on what you first plugged in as the first term, just adding 26 and so on and so forth. So if you wanted the, I don't know, the 100th step, I doubt you're going to want to hit enter 100 times, or technically 99. I doubt you're going to want to do that, but in theory you could hit enter 100 times. I wouldn't want to do that, frankly, but you could. The calculator has that ability. Okay, you just hit enter instead of having to retype everything, so kind of nice. But that is a nice kind of warm-up to a more, I think, efficient approach, which we're about to talk about on our next definition. An explicit formula expresses the nth term of a sequence in terms of n. The explicit formula for an arithmetic sequence is as such. You have a sub n again, but it's equal to the first term a sub 1 plus the quantity times d. The quantity in this case is n minus 1. That's the term number again, n. This is the first term again, a sub 1, while the common difference again is d. So all the same variables apply in context. The beautiful thing, however, about explicit formulas, as you're going to find out in a little bit, is that you can do much more, I guess you could say, term analysis, given only, let's say, the first term and the common difference. We'll talk about how this is going to apply here in a moment. Let's move on to example 3. Apply the explicit formula. The cost of renting a bicycle is given in the table. How can you represent the rental cost using an explicit formula? So let's take a look. Here's our table. We've got number of days rented versus the rental cost. So 1, 2, 3, 4 days measured against $26, $38, $50, and $62. In a sense, you can consider very much like a sequence that we've already seen, such that this would be a sub 1, which is equal to 26, a sub 2, which is equal to 38, and so on and so forth. And look, you can also see the distinction of the common difference. You are, in fact, adding 12, and so on to get the next term. So a sub 1, not surprisingly, like I said, is 26. The common difference, not surprisingly, is 12. Let's continue. To find the rental cost for n days, we're going to write an explicit formula for the nth term of the sequence. Use the explicit formula. A sub n equals 26, which again is the first term, plus the quantity n minus 1 times 12. 12 again being the common difference. You can continue by simplifying, distributing the 12, so 12n minus 12. And then you have 14 plus 2n. This should look very familiar. This is actually a slope-intercept form if you think about it. Y equals mx plus b. M being the slope here, 12, 14 being the y-intercept. The explicit formula for a sub is a sub n equals 14 plus 12n, and it gives the rental cost for n days. I do ask that you continue looking at the notes on your own. We will pick this up at a later time.